We are starting our last lesson on functions today. And this lesson on functions is actually going to be looking at the inverse function and how we find inverses of a function. Now, to explain an inverse, we're going to go back to the Sneetches, the video we started with to begin our lesson on functions. And if you remember from that video, the Sneetches were getting stars put on. They'd go through the machine, the stars were put onto their bellies. Now what we're going to do is the Sneetches found out that maybe the stars weren't so good, and they're going to be taking the stars off of their bellies. So they've got to go through a different type of machine. So watch the video.
$10 each. Belly stars, my dear friends, are no longer in style, and I'll have yours off in a very short while in my wondrous machine which eradicates stars. Then you won't look like Sneetches who have them on bars.
Eradicates these?
Eradicates these with the greatest of ease, provided you pay your $10, if you please.
Here's 10 for the boy and 10 for me.
Thank you.
How original.
How distinctive.
How exclusive.
Beautiful.
Okay, so in looking at inverses, we are going to undo what we did. Let's go ahead and take a look here at a formal definition of inverse functions. It says two functions are inverses of one another provided that f of g of x equals x for each x in the domain of g, and g of f of x equals x for each x in the domain of f. Okay, so they are inverses of each other basically if we take this guy, plug it into there, and end up back where we started with our x. Now, I'm going to come back to this later, but for right now, let's go through a few things that might help you understand an inverse. First of all, in order to find an inverse, find how we would what we would program our new machine to be to take the star off, or to undo what we did in the first machine. So we're going to go through an algebraic process, basically two things that you have to remember, but let's go ahead and take a function. We'll take f of x equals 2x cubed plus 3. So if we took a number and we ran it through our machine and we got our answer, if we want to go back to the original number that we put in, we would want to find an inverse here. So in order to find inverses, what we're going to do is, I'm going to rewrite this, be easier to see if I rewrite it as y equals 2x plus 3. And in this process, what I'm going to do is I'm going to let x and y trade places. So these two guys are going to switch. And once x and y trade places, then I'm going to solve the equation for y. That means I'm going to get y by itself. So in essence, I'm going to undo everything that's going on over here with the y. And I'll go through and show each step along the way. So now I have x minus 3 equals 2y cubed. Need to divide by 2. I want to get that y by itself. So I have x minus 3 over 2 equals y cubed. And to undo the cube, I'm going to do a cubed root. So what I finally end up with is the cubed root of x minus 3 over 2 equals y. This equation that we solved for here is the inverse then of this equation. They are inverses of each other. Now, our definition said that if we take our equation, one equation here, and plug it into the other, we should end up with x. So to verify that they really truly are inverses, we're going to do a composition of functions here. We're going to take this and plug it into that to verify that it is truly an inverse, and we should end up with x. Before I do that, though, I'm going to take you to a simpler problem. We'll do the same thing, but with another set of equations. So let's just go through this set of equations that I want you to try on your own. I want you to see if you can find the inverse of this function. So f of x is equal to 1/3 x plus 2. So go ahead and go through those steps again where x and y trade places, solve for y, and find your inverse. I'll give you a couple minutes to do that. Okay, so let's just double check here your work in finding the inverse. So our first step was we were going to let x and y trade places. And now we're going to solve for y. If I want to get rid of that 1/3, I'll multiply here by